So like I said, the number one way you get things to run on a machine is DLL hijacking. So let me show you this. And then we'll do kernel debugging. Those are things you should see. Now, you have to use a Intel machine for this right now because the ARM version of Windows 11 was written later and it no longer has the bug we're exploiting here. We're going to exploit an old service that has a bug. So I'm using this cloud machine, which is working fine. So, in fact, let me just open the project inside the cloud machine. There we are. And it's malware analysis and DLL hijacking. All right. So, the first thing, you have this has already been done on your machine to disable the Windows Defender and install Metasploit. And so you generate a malicious DLL, and here's the command that does it. You can run Metasploit on Windows, and this is MSF Venom, the same thing we used to make malware before, except now we make a DLL. It can make a library. So it makes a library file, a Windows library, which is malicious, and the way it works is as soon as it's loaded, it opens a listening shell, and it never does anything else. So that's convenient, but it's limited, as we're going to see. And I can show you here, if I open an administrator command prompt, or administrator terminal these days, they call it, and then I already put that in my downloads directory. Let me do Control Plus. Okay, there we are. CD downloads. All right, and so I've already run that program, and it's created this thing called shellbind.dll. So it's 8,000 bytes long. It's this little library. And so if I can trick any software into loading this DLL, it will run the malicious code. Now, the problem is, of course, I'm not able to modify the software. I'm using Windows software, so I have to find Windows software with a bug, and there is a bug in this process. And let me make sure the real-time protection is turned off, because Metasploit attacks are well known, and it will be blocked by Windows Defender if you give it a chance. So I have to turn off real-time protection, and that's here in virus and threat protection, system settings here, and you can turn it off, and it will automatically turn on after a while. So it's only going to stay off for a while, maybe until the next reboot. I think even less than that. They're pretty picky about it. So now there is, as you saw in the process monitor, Windows has a ton of services, and you don't need them all. This is the fundamental thing about Windows. Windows is the all-purpose operating system. It has hundreds of things you're not using in there. And so one of them is this thing called the Distributed Transaction Coordinator. As far as I can tell, it does something if you're running a database server, which nobody is on Windows 11. So it's just sort of a useless appendix. And right now it's not even running. However, in addition to being useless, it also has a bug, which we're going to exploit. So, and that's here, the MSDTC service. And so we can find out what's going on with Process Monitor. So let me launch Process Monitor here. And that's why this is nice. It also gives you an opportunity to practice with Process Monitor, which is really quite powerful. And so I've added a filter here where process name contains MSDTC and the path ends in .dll. So it'll pick up that thing running. So I start this sniffing there, and I think it's running. I see a number going up. Okay, so now I launch that process, which I can do here in services. I can start the service. And there it goes, and here's all the things that happened when I started the service. So I can stop sniffing and now look through here to see what happened. And here's the path and the results. You see most things worked, a few things had errors, and the errors are what's interesting to us. So let's just quickly scroll through them. We could also even sort by results, but we don't really have to. There's one of these that says name not found. And this is the one, that's the issue. What happened here is there's a module somewhere that includes this library, and it looks for it and doesn't find it, and yet it runs normally. So this happens if your developers put an include file, but they never actually use the library. It won't stop it from running, but it does try to load it. And this is what you need because the Metasploit DIL is a lousy imitation. It doesn't have any actual functionality. So you can load it, but there are no actual functions offered. So if you try to use it, your program would crash or complain or something. But since they never use it, it'll work. So all we have to do is add this file to the machine, and it will run when the net service is launched. So all you got to do is move that to the right folder. And so that is just this. Copy shell bind to C Windows System 32 OCI.dil. So that's here. All right, so shell bind is there. And I'd make this window smaller if I can get a grab. There we are. All right, so I copy shell bind. Oops, gotta spell copy better. All right, to C Windows System 32, and that's it. Oh, and now I gotta specify, it has to be named OCI.dil. Whatever OCI is, I'm impersonating it. So now I put a malicious file there, and now I start that process. And I can do it with stop and start here, or I can do it in the other panel. Net stop msdtc. Okay, that stopped. And now when I start it, it's going to try to load this malicious DIL. And because the malicious DIL is pretty sleazy, it's going to freeze partway through starting. But it's already running the malware. And you can tell, for example, you can do netstat -an pipe more, and you will see there's a listening port on 4444. So that is the malware running, and you can connect to it with ncat 127.0.0.1.4444, and I now have a different Windows shell. Notice I was a low privilege shell here, C user student. Now I'm System 32. If I do who am I, now I'm system, because that service was running a system. So I have started a listening port at high privilege because I've added that malicious DIL in there. So that's DIL injection, simplest case. Now this only works under pretty limited conditions. So I should mention, to really do it, the more powerful attack is the next one, DIL proxying. This one lets you attack something even if the full DIL is used. But it's more complicated. What you have to do is you have to use, you can impersonate a DIL. So here, you get a program, and this one here, the thing about this one is it loads the DIL only by name, not by the full path. So first it looks in the current working directory, and then it only looks in the system directory later. So this is called a companion Trojan. You put a copy of a file with the same name in a different folder, and it gets loaded by accident. This is pretty common. This is how the Stuxnet attacks work, among other things. So I can put it right here in the same folder as this and call it version.dil, which is the Microsoft library to tell what version Windows you have. And I can put it here, it'll run that instead. So now I know how to make it run it, but it has to impersonate the real version.dil, or the program will crash. So to do that, you use use Metasploit to make a malicious DIL, and you'll find it won't work because it doesn't impersonate the real version.dil. The program will just crash instead of letting you do it. The application was unable to start correctly. So what you have to do is build a DIL proxy. You use this thing called DIL Export Viewer to get a list of all the functions in the DIL. And this DIL is pretty simple. It has about 15 functions. And now you have to export that stuff and run a little script to generate the source code, which does it, and you end up with these pragma statements. These have to be added to the source code of the DIL you make. So you make a copy of the real version.dil in the same folder called old version, and you forward all calls to that library. So it's a proxy in the middle. You load this version.dil, and whenever it tries to use it, it'll forward that request to the real version.dil and give it the real answer, but it has extra malicious functionality added. And so you can build this thing in Visual Studio with a lot of careful settings, and therefore you can add an exploit here, and the exploit I wrote will just run a batch script from the desktop. So you can do anything you put in that batch file or in the root of C. So That's the game. So you end up with a source code that includes this stuff, and it includes an exploit function that runs payload.bat from the desktop. Yeah. What's that? Yeah, let's try that. Okay. Oh, thank you. Yeah. 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 So anyway, you can see here, DIL main is the process that's launched as soon as you load a DIL. And what the Metasploit payloads do is put malware in DIL main and have no other function. So it only works when you first load the DIL, but it'll crash when you try to use it. This one here has a DIL main where it will run the exploit and return true when this, and then it'll still have the functionality because of all these other ones. So it takes you a lot of steps, but you can make it a functional proxy. So even a program that's loading a DIL and using it will still work, but it will have this extra functionality. And I just made one where it makes a tag on the desktop, makes a file. So anyway, that's how you make malware to run in the Windows using DILs. So I wanted you to see that.